The only problem is when it's not oriented properly. I used to be able to rotate those, and now I don't know why I can't do it. All right. These kind of problems, 1, 2, 3, 4, 5, and 6, are all factoring problems and least common denominator problems. That's what they are. Okay?
Okay.
So always try to factor what you can factor. So if we look at number 1, well, x squared, I could go x squared, I'll just leave it squared, over x minus 2. Now if I'm going to multiply that, factor x squared plus 3x minus 10. How does that factor?
So that's let's see.
Start it off. Go through each step.
So 1, 10, 2, and 5. So
Okay, well, when I say go through
negative.
each step, break up the x.
Oh yeah.
Step 1.
So
Step
x
2,
and then
determine both signs. They're opposite.
minus and then
Now
yeah.
step
And then
3 is factors of 10 that subtract to the number 3.
right. So it's plus 2 and then minus 3.
It's, first of all, it's 5 and 2. And the bigger
Oh, right.
factor has to go with the sign of the middle term. The bigger factor is 5. So it goes with the plus sign. Smaller factor is 2. Okay.
Okay.
So we have factored the numerator. Now, how about the denominator? Anything factor out of that? In other words, this part.
So x plus.
When you're factoring, it's always something times. Always.
Okay, then.
Now, what goes in other words, you've correctly surmised that x is the greatest common factor. What's left over? X times what is equal to x squared plus 2x?
X plus 2.
Okay. In other words, is all we did was greatest common factor for that one. Okay. Now we can kind of see that this works a little bit better if I make it x times x instead of x squared. Because now what you're going to do is cancel wherever you see the same thing. Well, there's an x minus 2, there's an x minus 2. There's an x, there's an x. What am I left with?
X times x plus 5 over x plus 2.
And that's as simple as it can be. You can't simplify it any further. A lot of people make the mistake of thinking you can do that. You cannot.
Right.
Okay? All right. Let's do the second one. Actually, you direct me. We'll have time to do all of these. So let's just do them all.
Right.
Remember, these are factoring problems. The second one is a division problem. Am I correct? Is that a division sign or a plus sign?
It's I think it's a division sign.
Okay. So how are we going to divide?
So you would flip the second one and then you'd multiply it.
Okay.
So
good. So we know that's what we're going to do. So now let's handle that part.
All right. So
top left.
So these are harder. So
some aspects of the movie you would.
Oh, I hear a lot of background noise. That must be hard for you to focus.
Some of the jokes.
No, not really.
Okay. Factor the top.
So, all right, I don't know.
What is that? Is
So,
that 2x cubed?
yeah,
Okay.
no,
What's the
it's 2x
greatest common
squared.
factor? What's the greatest number you can
Oh,
take out?
2,
What's the greatest variable you
x,
can take out?
2x. So,
Okay, that's the greatest
and
common
then,
factor then. What's
all
left
right,
over?
x minus
Uh-uh.
6.
No. Whenever you figure out what's left over, always do that multiplication. Does that equal 2x cubed?
It's 2x squared.
Ah, so that's got to be x squared then. Is that supposed to be, is that 2x cubed? I really can't read it.
No, it's 2x squared.
Okay, then if it's 2x squared, then you were correct the first time. What's the rest of it?
Minus 6.
Okay, factor the bottom.
And
These
then,
always are factorable. These kind of problems are never going to require the quadratic formula. It's just they don't do it that way. They make them factoring. These are practice with factoring is what they are.
okay. So it's both x, and then they're both negative, and then 6, and then 1. So x minus 6, and then x minus 1.
And always remember that you're probably going to run into some of these factors a couple of times. In other words, the fact that that was x minus 6, when you get anywhere close to it, you know that's going to be x minus 6. Okay? And I'm multiplying by the reciprocal of that. So the bottom is 2x. What's the top?
3 times x minus 1.
Good. In other words, you're always factoring, always. Now you're always canceling. There's a 2x, there's a 2x, there's an x minus 6, there's an x minus 6. So what I'm left, there's an x minus 1, an x minus 1. What's my answer?
3.
Okay. One last test or question
So
that I want to make sure you understand the answer to this. What is that equal to?
1.
-1.
Wait, -1. Yeah.
If it was over x minus 4, it'd be equal to 1. In other words, x minus 4 over x minus 4, those are always equal to 1, anything divided by itself. But in this case, we're dividing a minus b by b minus a. Those things are not the same thing. But it's the one case where you're doing these kind of problems where you can cancel. Notice that
Okay.
every single other problem we did, they had to be identical. Not this problem that I just gave you. If they are a minus b and the other is b minus a, then you can cancel that and replace it with a -1.
All right.
All right, number 3. Let's see. Let me write it, make sure I got it. 2 over x minus 1. What's the rest of
Plus 4 over x plus 2.
it? Okay. How do I add fractions?
You try to get common denominator.
You actually try to get the least common denominator. It actually will work if you just get a common denominator. What's the least common denominator here?
X.
Don't multiply it
No.
out. That's a mistake.
Yeah. Yeah.
It's x minus 1 times x plus 2.
Okay.
In the same way that if I said if I'm adding 1/3 to 1/4, there always is a common denominator by multiplying the two bottoms. 12. Now, sometimes you want the least common. In other words, common denominators will always work. They'll just make the problem harder. If I'm adding 5/6 to 3/8, I'm not going to use 48 as a common denominator. I'm going to use 24 because it's smaller. But when you're dealing with variables like x's, generally you pretty much have to multiply it. Not always. Sometimes they'll give you a problem where you don't have to multiply the two variables. Maybe they'll give us one, maybe they won't.
Okay.
That's our common denominator. Now, what goes in the top left? And it's very important not to multiply these together, and you'll see why in a second.
So top left is 2 times x plus 2.
Yeah, and you can see why it's a good reason to write it this way. Because I can instantly now see that that is exactly the same as that. That's your goal, is to not change anything. Don't even distribute this yet, the 2, because it keeps you from seeing that you haven't changed anything. So what's the right numerator?
4 times x minus 1.
Okay. Now what's the answer? The answer we know is going to have a common denominator of x minus 1 times x plus 2. Again, we're not ever multiplying those. Out. Okay, now what's the top? In other words, now you have to operate on all of that. What does that equal to? Just do it piece by piece and I'll write it, and then we can do the simplification as a second step.
Okay, so 4x or 2x plus 4 plus 4x minus 4.
Okay, which is what?
Oh, you think so?
6x.
That's your final answer. That cannot be simplified.
Oh, he was going to get a drink.
Okay.
Okay?
Are you ready to go get a drink?
All right. Let's look at number 4. Solve and list all extraneous solutions. So there's kind of a warning. We expect there to be extraneous solutions here. Okay?
Okay.
Work with actually, I don't want to ignore a really neat trick that I like to use on these kind of problems. In other words, you got 2 choices here. I can find the least common denominator for that, operate on it, proceed from there. But remember, when you're solving algebraic equations, you want to get rid of denominators. My 2 goals are always get rid of denominators, get rid of parentheses, get rid of exponents, but mainly denominators and parentheses. What's a great way to get rid of the denominators all in one step?
So multiply
Everything by what?
the common denominator.
Which is?
X minus 6 times x.
Perfect. X minus 6 times x. I'm multiplying the whole left side by that, which means I got to multiply the whole right side by that. Now, what's the left side become? In other words, what is all of that equal to?
So cross out the x minus 6.
What's left behind?
5x.
Perfect.
and then plus
Is that a plus or a minus?
a plus.
Are you sure? It looks like a minus to me, and it's a better problem if it is a minus.
It's a plus.
It's a plus, okay. I guess it doesn't have anything to do with being a better problem. It has to do with whether it's an equation or not. So, okay, and what's next? In other words, what's all of that times that?
Then it's just x, or x minus 6.
Okay. The reason it would have been a better problem if it was subtraction is because then I would need parentheses. Otherwise, I'm going to get it wrong. Whenever this is subtraction in this kind of a problem, make sure you put the whole thing in parentheses that you're doing. Okay? But in this case, I'll take your word for it. It's addition, and that's all equal to what? What happens when I multiply the right side? In other words,
it's all equal to x squared minus x.
Okay, now what are we going to do?
Then move everything to the right side, and then equal it to 0.
Okay, so what does the right side become? There's only one x squared term. How many total x's do we have?
Negative 6x.
I got positive 6x right there. If I move the whole 6x to the right, then it's
negative 7x.
7x. Okay, and what number?
Minus or plus 6.
Okay, now factor that.
So both x's, and then both negatives. 1 is 6, 1 is 1.
What are my two answers?
X equals 6 and x equals 1.
Now I want you to check both of those answers with the problem. Is there a problem with any answer?
X can't be 6.
Okay, so that's an extraneous solution. And they wanted you to identify list all extraneous solutions. So you want to list x equals 6 as an extraneous solution. And what is a valid solution? The only other one is 1.
1.
And 1 does not violate any of the domains.
Right.
If you were to test 1, that would remain an equation. You can't test 6 because you can't divide by 0. So there's no way to even test 6. Once you see that one of those solutions causes division by 0, you're done. Throw it out.
Okay.
Okay. Number 5. A similar problem. What do you suppose the factors of that quadratic on the right side might be?
X minus 2 and x minus 6.
What am I going to multiply both sides by?
X minus 2 times x minus 6.
Okay. What's that give you on the left?
So it's...
Don't do all the math in your head. I prefer it if you don't do the math in your head.
Right, yeah. So it's x times x minus 6, and then plus then x minus 2 plus x minus 2.
Yeah, and I'm going to put parentheses around it even though they aren't needed. I'm just going to do it to get you in the habit of doing it.
Right.
Because they definitely are needed if that's a negative sign instead of a plus sign in front of the parentheses. And what's the right side give you?
4.
Now, isn't that problem so much easier? In one step, we turned it from a ridiculously hard-looking problem to a super easy problem. Okay, finish it off.
So x minus 5x minus 2 equals 4.
Hold on. Make sure you're differentiating between adding and multiplying.
Right.
Multiplying, what's x times x minus 6?
X squared minus 6x.
Now keep going.
And then times x minus 2.
Not times.
Or plus x minus 2. So then, wouldn't that be x squared minus 5x
Yep.
minus 2?
I just didn't know you were skipping steps, so I didn't know. Now what's the final number? In other words, we're looking at a quadratic, so we want everything on the one side and 0 on the other. So what?
Okay. Equals 0.
Leave that 4.
So
minus 6. Exactly.
Mm-hmm.
Now you can solve it like any quadratic.
So one is positive, or both x's, and then one is positive, one is negative, and then positive 6 and negative 1.
Remember, the bigger factor has to go with the sign of the middle term. So you got the two factors correct, 6 and 1. But that is negative. So the bigger factor has to go there. Otherwise, there's no way you can produce that minus 5x in the middle. Okay. Now, what are my two solutions?
X equals negative 1 and x equals 6.
Now let's check those solutions. Which one is not valid?
X can't be 2. So the 6 does not work. So x equals negative 1.
Correct. That's the answer, and that's what you would list as an extraneous solution.
Okay. Cool.
Okay. All right.
All right.
Okay. Domain and range. The biggest thing to think about with domain and range is how to think about domain. How do you think about domain?
So
when I say that, what I mean is what you really try to figure out is what can x not be? It's not so much what can x be, it's is there anything x cannot be?
So
what can x not be in what I've circled?
x can't be 3.
Okay, that's first rule of math. All math, worldwide. Okay. You cannot divide by 0. So you can never allow division by 0. Well, the only thing that causes division by 0 is x equal to 3. No other number. In other words, x can be all real numbers. When it says identify the domain and range, is this a good enough answer, or do you need to give interval notation?
Interval notation is what he prefers.
Tell me what interval notation is that equals
that. Negative infinity to 3, or yeah, and then 3. What?
Do I need a parentheses or a bracket?
Oh,
the 3.
Parentheses.
In combination with?
3 to infinity.
That's that's the easy part. The range is really a lot more difficult. Always. Domain's always the easy part. Okay? Range requires you to think out of the box a little bit. let's deal with this quantity right here. Can that ever be equal to 0?
Yes.
How? What value of x would make that equal to 0?
3.
No. 1 divided by 0 is not 3. It's not 0, rather. This doesn't exist. It is definitely not equal to 0. In fact, it's as far away from 0 as you can get. It's either positive infinity or negative infinity, but it's not 0. For something to be 0, the numerator has to be 0. So there's nothing that will make that thing ever equal to 0. Can you get close?
Yes.
What kind of value would x need to make that thing close to 0?
3. X equals 3.
Divided by 0. That is a mathematical law.
Oh.
That is the head of everybody's list. You just can't do it. So don't ever even put in a solution in there that divides by 0. That's never the answer. How about a million? How about a billion? In other words, if I let x get really, really big, if I let it approach infinity, then this whole thing approaches 0. So the smallest this quantity can ever be is 0. It can be negative, but in other words, if x were negative a million, then it would still be very, very tiny, but it would be negative. In other words, it can only approach 0. So if I add 4 to something that can only approach 0, what's the smallest that this thing can be? You know what?
4.
I'm doing this wrong. I just reread the instructions and it said graph. And this is much easier to figure out if you graph it. Okay. Now, the thing is, how do I graph that? What's the parent function?
It's y equals 1 over x.
Which looks like this. Hyperbolic.
Right.
Okay.
Right.
Now, the minus 3 does what?
It moves the horizontal asymptote up 3.
No, it's a horizontal shift for sure, 3 units to the right. But notice what it moves is the vertical asymptote, not the horizontal.
Okay.
In other words, if I draw a vertical asymptote, it's going to go where it was the y-axis. It's now going to go through that. Okay. And the horizontal asymptote was the x-axis. Well, what happens to it when I add 4 to everything?
That moves up 4.
Correct. So that's our new asymptotes based on the horizontal and vertical shifting. And so if I'm going to graph that, I'm going to graph it based on this new grid. It still looks like that. In other words, it still follows everything. Okay? So now I want you to focus on the blue. I want you to make your eyes look left and right. Can you see where the domain goes from negative infinity to the number 3 and never crosses the number 3, which means it's never allowed to be 3. And then on the other side of that asymptote, it goes on to positive infinity. X does.
Right.
So this verifies that the domain is all real numbers except x equal 3. Well, we can get the range just as easily. What's the range? This time I want you to train your eyes to look up and down only at the blue curves. In other words, you got this curve here, and you got the other half of the hyperbola up there. So what values are covered by the range?
Would be negative infinity to 0.
Not to 0.
And then,
what is the cross?
2. 4.
Right. In other words, that's the only thing this thing can never be. And the reason it can never be 4 is because that can never be 0. In other words, the first part of it would have to be 0 for this thing to ever be 4. And we've already realized that that left part can never be 0. And we can see from this part that it covers all values greater than 4, so it's in conjunction or in union with from 4 to positive infinity, everything being parentheses.
All right.
And frequently, range, the best way to find range is by studying the graph. It's hard to figure out range without studying the graph. Domain, you can do it easily, but since they wanted you to graph it anyway, I figure we might as well graph it and then figure out the range and the domain. And yeah, let's do this one. Hold on, let me use a different color for the parent function. In other words, let's do this one the same way. It's hyperbolic, right?
Uh-huh.
So what's this x plus 2 in the denominator mean?
That moves the vertical asymptote to the left 2.
Okay. And the plus 7?
That moves the horizontal asymptote up 7.
Okay. So that's our new grid that we're working on. Now, at this point, I don't really know whether the graph looks like this or maybe like this. That negative sign in the numerator gives me doubt. And I could do some more math to figure out whether it's the blue curves or the green curves. But notice that it doesn't really matter, does it? I guess it does because they ask you to graph it. So let's figure out whether it's the blue curve or the green curve. How am I going to do that?
So,
in other words, it doesn't matter for the domain or the range, notice. Either the blue curve or the green curve is going to give you the same domain and the same range. But since they asked us to graph it, we got to know which one is correct. How do we tell?
So
pick an easy x value. What's an easy x value?
3.
About 0.
Okay. Yeah.
Is that x plus 2?
Yes.
Okay, so if I use 0 for x, then my answer should be minus 1 over 2 plus 7, correct?
Yes.
Which is 6.5. Is it my blue curve or the green curve that's correct? Remember, x equals 0 is right there.
So it's the green curve?
Yeah, that's at 6.5. though I don't know exactly where it is, but I know it's below that horizontal asymptote, and that horizontal asymptote's at 7. So the fact that I know that it's below 7 means it has to be the green curve. It can't be the blue curve. And that's all you have to do is pick a point for x that's on one side of that vertical asymptote or the other and figure out which curve works. And in this case, it's the green curve. So the green curve is the one you'd want to graph. And now tell me the domain and range.
Okay.
What's the domain?
Negative infinity to -2, and then -2 to infinity.
Okay, notice that's also the domain of the blue curve. What's the range?
Negative infinity to 7,
Uh-huh.
and then 7 to infinity.
And that's also the range of the blue curve. So you could have gotten the domain correct and the range correct with the wrong graph. That still would have been valuable. You'd have still gotten points on the problem. You might have lost a point for giving the wrong graph. But to get the right graph, always know that these hyperbolic functions are usually in quadrants 1 and 3 or 2 and 4. And to figure out which, just plug in a value for x.
Okay.
All right, let's see. So that takes us to number 8. Simplify. Which means what? What kind of problem is this?
It's a factoring problem.
Okay, factor the top.
X times
Does that top
x.
say x squared minus 9?
Yes.
Okay, factor it.
Or wait.
It's difference of perfect squares. How do you factor
Yeah.
difference of perfect squares?
So it's x plus 3, x minus 3.
Okay. Factor the bottom.
So both x's, one positive, one negative, and then the negative one is 3, the positive one is 2.
Okay. Now, notice you can cancel something.
Mm-hmm.
But in other words, this thing turns into this. Okay? But not quite exactly. In other words, just because I was able to cancel that and that did not take away my domain restriction. X is still not allowed to be 3. Even though, if you look at this over here, it looks like x being 3 is fine. You end up with 6 over 5. So there's nothing wrong with x being 3 on the far right side of the final answer. But just because I canceled a linear factor does not take away the restriction that x cannot ever be 3. Now, I don't really like this because it's not an equation. So when you simplify stuff, you don't really have extraneous solutions, but the solution they're referring to here is x equals 3. In other words, x cannot be equal to 3. So when you simplify it, you get this over here, x plus 3 over x plus 2. And the extraneous solution is x cannot be equal to 3. And what that translates to is a hole. So if I'm graphing this, I might have a graph like that, but it's going to have a hole at x equal 3 right there. And it's going to show up like that. So one thing to understand about that is that means that that is not exactly the same as that. This has a hole in it. If I look at strictly the final answer, there's no hole there. If I give a final answer of x plus 3 over x plus 2, it's this graph without the hole. So the fact that the problem started out like that means that hole carries forward all the way to the end, even if it's not a hole in the final answer.
Okay.
Okay. If there is a vertical asymptote at x equal minus 1, what's that make h?
H is...
What this tells you is that when x is minus 1, that denominator is 0, right? So let's plug it in. Minus 1 minus h must equal 0. That's the only way. In other words, this thing has to be 0 when x equals minus 1. That's what vertical asymptotes are. That's division by 0. And now if I solve this, I get h equals minus 1. So I've solved for h. Okay. And it has a horizontal asymptote at y equal 8. What's k?
Okay.
Remember what happens when
So,
you have a vertical shift. That is a vertical shift, correct?
yes.
When you have a vertical shift of a hyperbolic function, what happens to the horizontal asymptote?
It gets moved
By that
to...
amount.
Okay, yeah.
If I don't have the plus k, the horizontal asymptote is y equals 0.
Right.
With
So K
the vertical shift, and now they're telling us the horizontal asymptote is y equals 8, that means k must be 8.
Okay.
Now, write an option for the equation of this function. Well, let's see. Y equals a over x plus 1 plus 8. Now, the only thing we didn't solve for was a.
It doesn't give us anything for A.
And I don't think it gives us enough information to figure out a. In other words, we know that a is not x, it's a number, but that's all we know.
Yeah.
So I think that what we've written here is the answer for part A. I don't think we can figure out what the letter A is. I might be missing something in looking at this, but I don't think so. And it certainly is not going to affect the domain and the range.
Okay.
Okay. What's the domain going to be? Do this one algebraically.
So.
Doesn't even ask us to graph it, so let's not graph it. Let's figure it out, the whole thing algebraically. What can x not be? When you're figuring out domain, always start with that. What can x not be?
-1.
So the domain is what?
Negative infinity to -1, and then -1 to infinity.
Now, range. Again, this part can never be 0. In order for that to be 0, a would have to be 0. And we're assuming a is not 0, although they don't say that anywhere. Theoretically, a could be 0, but we're going to make an assumption that a is not 0. So The only number that y cannot be is what? If this can never be 0, what can y never be?
8.
Okay, so what's the range? That's all you need for the range.
Negative infinity to 8, and then 8 to infinity.
Yeah. And you can do it without graphing it. If we did graph it, it wouldn't be that strange of a looking graph. We know the vertical asymptote goes through -1. Horizontal asymptote goes through 8. They told us that. So if I'm graphing this, it's probably something like this. And there's no negative signs. I guess if a was a negative number, the graph would look more like this.
Okay.
Okay? So that's why they don't ask you to graph it, because it depends on whether a is positive or negative, whether you get the green or the blue. But notice again that it did not affect the domain or range whether I used the green graph or the blue graph. The domain and range were exactly the same.
All right.
All right. So, you got any other issues or questions? We got 10 minutes if you like to review anything that you're not totally comfortable with.
Nope, that's actually it.
Okay. You feel like you're good to go?
Yep.
Well, good luck on your final.
All right, thank you.
Yeah, by all means, next fall, you're taking pre-calc and trig. I'll probably start you off with pre-calc in the first semester, and then you'll do trig in the second, is usually the pattern they use. But yeah, by all means, if you need any help, keep me in mind.
Okay. Yeah, I will.
All right, Dimitri. I will talk to you. Have a good summer if I don't talk to you again this summer.
Yeah.
All right.
All right, thanks.
Bye-bye.